We begin a new topic, sequences and series. This is part 1. In this video, we are going to discuss the quadratic sequences. Consider the following number pattern: 2, 3, 6, 11, etc. Determine the nth term or general term. We have no idea about this number pattern, whether it is quadratic or not, but we are going to check. Now that numbers are there, we calculate the first differences. T1 is subtracted from T2, that is T2 minus T1, or T3 minus T2, or T4 minus T3 will give you the first differences. Then we see that those numbers are not equal, they are all different. We continue. Again, we calculate the second differences. Look at the second differences. We find that they are equal. Once the second differences are equal, we realize that this number pattern is a quadratic pattern. So we are going to find the general term. The method is we take 2a equal to 2. From there we solve for a equal to 1. Again, the first term of the first difference, that is 1. We take 3a plus b equal to that number. And from there we substitute a and solve for b. We get b equal to minus 2. Lastly, the first term of the sequence is 2. Okay, so we take a plus b plus c equal to 2, and then we substitute a and b. Solving for c, we get 3. Now the general term or the nth term is Tn equal to an square, a quadratic expression, power 2, an square plus bn plus c, which is equal to a is 1, so it is n square, b is minus 2, so we get minus 2n plus c is 3. So that is the method, good people. Question continues. Question B, determine which term will equal to 1091. Which term? Meaning we have to find the value of n. So we start. Tn is available, that is 1091, and we have already calculated the Tn, that is n square minus 2n plus 3 equal to, then we make it into a standard form, equation in the standard form, then we factorize, or we can use the formula. N equal to 34 or n equal to negative 32, but n cannot be a negative number. So our answer is n equal to 34. Okay. So what do we understand? The 34th term will equal 1091. Got the answer. Another question on quadratic pattern, 15, 29, 41, 51, etc. Determine an expression for the nth term. Okay, so we repeat the method again. We have the first differences. We calculate the first differences, 14, 12, and 10. We calculate the second differences, that is minus 2. And the method 2a is equal to minus 2. Solving for a is equal to minus 1. 3a plus b is equal to 14. Solving for b, we get b equal to 17. And a plus b plus c equal to 15. Solving for c, we get minus 1. And this general term, an square plus bn plus c, for this question it is minus n square plus 17 and minus 1. Okay, so that is another indirect question. 2x 12y are the first 4 terms of a quadratic sequence. If the second difference is 6, calculate the value of x and y. Okay, so we start and go up to the second difference. Okay, first difference says x minus 2, 12 minus x, y minus 12. Second difference says, again we continue very carefully, we simplify, we get 14 minus 2x, we simplify, we get x plus y minus 24. Now the question says the second difference is 6. So we have 14 minus 2x as the second difference, which is equal to 6, and we solve for x. So we get x is equal to positive 4. Again we have second difference 6, x plus y minus 24 equal to 6. We have already got x is 4. Then we solve for y from the equation, y is equal to 26. So we got x and y. The sequence 3b 1927 forms the first differences of a quadratic sequence. Remember that this is the first differences, and the first term of the quadratic sequence is also available. It is 1. So we have to be very careful. Don't think that this is the sequence. Okay, now determine the fourth term of the quadratic sequence. Okay, let us start from the first differences, that is 3b 1927. Okay, we are trying to do few good questions. From them you must know the methods and techniques to answer the questions from quadratic sequences. That is the purpose of this video. So 27 minus 19 gives us the second difference, that is 8. And this is a quadratic sequence. So second differences must be same number. We have another 8. How do we get 8? 19 minus b must be 8. Or b plus 8 must be 19. Or 19 minus 8 will give you b. How much is b? b is 11. We are going back to the quadratic sequences. Okay, so if we have the first differences now, look at that. First number, first term is given in the question 1. So the second term must be 1 plus 3, 4. And the third term must be 4 plus 11, 15. And the question for the fourth term, 15 plus 19 gives us 34. So T4 is equal to 34. We got the answer. Given the quadratic sequence 4, 4, 8, 16, etc., between which two consecutive terms of the quadratic sequence will the first difference be equal to 28,800? 2888. The first difference, the number 28,088 is in the first differences. So we have to calculate between which consecutive terms of the quadratic sequence. Okay. So let us go and find out the first differences. So we subtract T2 minus T1, T3 minus T2, T4 minus T3 will give us the first differences 0, 4, 8, etc. Now this is seemingly a linear pattern with common difference. 4 minus 0 is 4. 8 minus 4 is 4. So we find that it is a linear number pattern. And we have to calculate the general term Tn equal to a plus n minus 1d. We can get it as simple as possible, which is 4n minus 4. What is our question? Between which two consecutive terms of the quadratic sequences will the first difference be equal to? So 28,088, which term is that in the linear pattern? That is our first job. So we calculate using the nth term, that is Tn, 4n minus 4. From there we solve for n. N is equal to 7,023. Then we write between 7,023rd and 7,024th terms of the quadratic sequence. Okay, the first term will be 28,080. That's the meaning of the question. Okay, so we must calculate very carefully. Another good question from quadratic number pattern. 1x, 1 minus 2y, etc. up to minus 322. Solve for x and y. So we will calculate the first difference and then we calculate the second difference. We have the first difference now. We have no idea about x and y. Then we go for the second difference. Okay. What we know about second differences? For a quadratic sequence, the second differences are equal. So we equate x minus 4 must be equal to 2 minus 2x. From there we solve for x equal to 2. Again, y plus 5 must be equal to x minus 4. Substituting for x equal to 2 and solving for y, we get y equal to minus 7. Question continues. Number B, calculate the number of terms in this pattern. So once we get x and y, we can substitute into the sequence. We get the numbers. Our question is to calculate minus 322. Okay, calculate the number of terms up to minus 322. So we go ahead with the first differences and then we go for the second differences very carefully. Second difference is minus 2. Then we continue our usual method. 2a equal to minus 2, therefore a equal to minus 1. 3a plus b equal to 1. Substituting a equal to minus 1. Solving for b, we get b equal to 4. And then a plus b plus c is equal to 1. Substituting a and b, we get c equal to minus 2. Now we are going to solve for n. Tn is equal to, okay, we can write the general term minus n square plus 4n minus 2. But we are given the last number. Okay, the last number is minus 322. Then we solve, change it into standard form, factorize. We have n equal to 20 or n equal to minus 16. We don't need a minus value for n, therefore n equal to 20. What's the meaning? There are 20 terms in this pattern. So that is the end of part 1 of sequences and series. We discussed quadratic sequences. Hope you understood. Watch again and again, and don't forget to subscribe this channel. Okay, good luck.